In this video, we're going to go over Science Paper 2 for the year 2014. Now we have our first question. Figure 1.1 below shows a setup of apparatus that can be used to show the process of diffusion. Then if you look at this setup here, we have carbon dioxide, which is being allowed into this gas jar. Then we have the liquid under level P and also level Q. So question A, explain the meaning of the term diffusion. So say this is the movement of particles from the region of high concentration to a region of lower concentration. Okay, so this is what we can say about this one. Now we move on to question B. Explain the purpose of carrying the gas jar with the cardboard. So if we go back to our diagram, we have this cardboard here. Then inside the gas jar there is air, and also we have this tube which is acting as the passage for carbon dioxide. So the carbon dioxide would diffuse from this region of high concentration into this region of lower concentration. So that's the picture that we are looking at here. So the reason behind the cardboard cover is to prevent the entry and exit of air. So we just want the air and the carbon dioxide to remain inside. So to prevent entry and exit of air and carbon dioxide. Okay, we move on to question C. Before carbon dioxide is introduced into the gas jar, the water level in both arms of the U-tube is the same. When the carbon dioxide is introduced into the gas jar, the water level at P and Q changes as shown in the diagram. Roman number 1, describe the cause of the change in the water level at P and Q. So firstly, we are going to maybe draw a picture that will give us how this setup was before the introduction of carbon dioxide. So we have this U-tube. So at first, the water levels were at the same height. For example, P were at this point before the introduction of carbon dioxide, even here. So if we maybe introduce some concept of forces, there should be a certain force produced by the air, and also here there should be a certain force produced by the air. So this force produced by the air here must be equal to this force produced by the air this side, so that this water level remains the way it is. Now what happens in a case where this air becomes less denser than this one here? So whenever it becomes less denser, then this water will push out. Then since this one is more denser, this will push water down. I'm sure you are getting the picture of what happened here. Now what made this air to become less denser than this side here? So the introduction of carbon dioxide. So if you look at the relative molecular mass for carbon dioxide, or maybe the explanation in terms of density, we know that carbon dioxide is more denser than air. So the point the carbon dioxide reached in this position here, then this air became less denser, and because of that it moved upward. Because of moving upward, then this air here became more denser. It pushed the water this side, then here it went upward. So that is what happened here. So say because the carbon dioxide pushed the air upward, causing the water level at P to rise. So I said to rise. So that's the explanation that we can give here. Now we move on to question Roman number 2. State what would happen to the water levels at P and Q if carbon dioxide gas was replaced by hydrogen gas. So let's go back to our diagram here. So we are saying instead of the introduction of carbon dioxide into this setup, let's take it for instance, we put hydrogen. Now if you look at hydrogen, hydrogen is considered to be the most lightest gas. So whenever this hydrogen is introduced here, the hydrogen will go up because the air is denser than hydrogen. So the hydrogen that we are introducing in this gas jar will force the air that we have in the porous spot to push down. So whenever this one is pushed, then the opposite happens. So the air this side, becomes less denser. As a result, now it will move upward. So this is what will happen. So say the water level at Q would rise because the air in the porous spot becomes more denser. So that's the explanation that we can give here. Okay, so we move on to question 2. The diagrams below show 4 different methods of separation. So we have the first one. This is a separating funnel. Then for this one, we are dealing with ascending, since the spots are expected to move upward. So this is an ascending paper chromatography. Then for C, we are dealing with filtration here, since we can see the residue on top of the filter paper. Then the last one, D, since the liquid or substance that we have, a solution in general, is heated, so this is evaporation. Now let's see the questions that we were expected to answer. Using the letters A, B, C, or D, identify the method used to separate insoluble particles from water. So for this one is C. So it's C, which is filtration. The insoluble part we know remains on the filter paper, while the solution or a liquid will pass through the funnel, then it will be collected as a filtrate. Then Roman number 2, separate a mixture of different dyes. So different dyes, we are looking at the color. So this is we are using letters, so which is B. Then make crystals of copper 2 sulfate from copper 2 solution. So it's evaporation. Then separate water and cooking oil. These two are immiscible liquids, so they can't mix completely. So it's separating funnel, which is A. Or for this one, I'm supposed to use a letter. So evaporation is D. Then start one industrial application of chromatography. So we'll say chromatograph can be used to know if the money, which is the currency, is forged. So say to check for counterfeit. For counterfeits notes. Then we move on to question 3. So under question 3, table 3.1 below shows the ions present in 1 liter of mineral water bottled for drinking by an industry. So how? The first column, name of ion, formula of the ion, then the last one is mass of ion present in 1 liter per milligram. So the first question that we have is define the term ion. So say an ion is a charged atom or group of atoms. So sometimes it may be group of atoms. For example, if you look at polyatomic ions like hydroxide, if you look at also sulfate, so these are ions. So these are also ions now, but they are polyatomic ions made up of more than one atom. Then question B, identify the cation with the lowest concentration in the mineral water. So cation, we are looking at a positive charge. So we need to look at the one with the lowest number from the concentration. So the cation, we only have sodium and calcium. Now the one with the lowest number is the sodium. So we can see that sodium is 4.0, while the calcium is 5.0. So sodium is in the lowest concentration. So say sodium plus, since they want a cation. Then question C, complete the equation below to show how a calcium ion is formed from a calcium atom. So this equation is known as the half reaction. Now this half reaction is for oxidation. So how do you know that is for oxidation? Because whenever we see a +2, it is giving us a picture that the 2 electrons were given out. So oxidation, electrons are given out, then reduction, electrons are taken in. Now how do you complete an incomplete equation like this one? So you just have to look at the number of electrons that were given out. So from the positive sign, we have 2. So you just have to put 2 minus. Then D, when this sample of mineral water is evaporated to dryness, various compounds remain as residues. Give the names of 2 of these compounds. So there's compounds that can remain as residues after evaporation, must be in salts. So from the table, the first one, we can see that we have sodium chloride is there. How do we know that sodium chloride is there? Because there is this sodium and there is this chloride, which is chlorine. Then what else? We also have calcium. Calcium sulfate is also a salt. So the second one is calcium sulfate. Then state the type of bonding found in the various compounds in the mineral water. So let's go back to our table. So from the information that we are given, we can see that we are dealing with ions. So whenever you are given with ion, then the compound or compounds associated with an ion where you're given a charge is an ionic bonding. So say ionic bonding. Under covalent bonding, we are not given charges. Okay, we move on to question 4. Salts are prepared in a laboratory using several general methods. Table 4.1 below shows some different methods of preparing salts. Complete the table. So we have the first one is precipitation. This one gives us insoluble salt, remember. Now, whenever you're dealing with insoluble salt, in order to find the name of the reactant, you just have to remember that you need to use two soluble reagents. So now, for name of salts formed during this precipitation is barium sulfate. Then name of reactant. So we need two salts or solutions that we can use to form barium sulfate. So now the key point here is, look at the salt that you are producing. There is barium. So you write barium. Then the other ion is sulfate. So the point is, you need to choose two salts in which one has a barium sulfate, barium, then the other one has a sulfate. So that's a pattern here. Now, the two salts or solutions that you are choosing must all be soluble. So, for this one, we can just say barium nitrate. So this is our first reactant that we can give. So we'll say barium nitrate. Why do we choose barium nitrate? Because all nitrates are soluble. Remember that. There is no exception. Then for sulfate, we'll just say sodium sulfate. So sodium sulfate is any salt made up of group 1 are all soluble. So even this one is soluble. So we'll say sodium sulfate. Then why have I chosen these two reactants? So that during the reaction, this sodium will displace barium, getting sodium nitrate, while barium will get the sulfate, giving us the salt that we want, which is our barium sulfate. We move on to Roman number 2. We have neutralization. Neutralization is a type of reaction that occurs between a strong base and acid. Then we are given name of reactants. So potassium hydroxide and sulfuric acid. So this name of the salt formed is potassium. So for a salt, naming of a salt, you always begin with a metal. Then from the sulfuric word, you just get the sulfate. That's a pattern. Hydrochloric, you get chloride. Nitric, you get nitrate. Then for Roman number 3, acid and carbonate. Then here we'll have copper 2 nitrate. So which acid can we use? We need to use nitric acid so that there is the presence of this ion of nitrate. So we need to use nitric acid, or the nitric acid will contribute the nitrate, this. Then we need a metal carbonate that will contribute copper. So this should be copper 2 carbonate. Then we have our answers as required. B. Write down the ionic equation for the precipitation reaction in the table 4.1 above. Include state symbols. So in order to maybe give you a more picture here is that, remember I said you need a soluble salt as a reactant plus another soluble salt as a reactant. Then you get the product, which is the insoluble salt, the one that you want. Then plus soluble. So for products, one must be soluble, then the other one must be insoluble. Why? So that during the filtration, the soluble will be filtered as the filtrate in form of solution in the collecting beaker, while the insoluble salt, which is our sort of interest, must remain as residue on the filter paper. So the soluble salts that we chose, the first one, we say the sodium sulfate plus barium nitrate. Then the insoluble salt of interest is barium sulfate. It's the salt that we want. Plus then the soluble will be sodium nitrate. Then let's write these into chemical symbols. So for sodium, has a symbol of Na with a valence 1, then sulfate we have a valence 2. So if we interchange, the chemical formula will give us sodium 2 SO4 in aqueous plus barium. Barium has a valence of 2. Nitrate is a radical with a valence of 1. So whenever the subscript is greater than 1 for a radical, you need to enclose that in brackets. So this will be barium nitrate in brackets. Then we put our subscript here, which is also aqueous. Then for barium sulfate, barium has a valence of 2. Sulfate has a valence of 2. So whenever the valences are even, you need to cancel them, giving you barium SO4. For this one is solid plus the sodium valence 1 nitrate NO3 in aqueous. Then we just have to add to balance our equation. So we just have to put 2 in front of sodium nitrate so that we have 2 atoms of sodium. And so our equation is balanced. Now this is we have word equation, then we have chemical equation. Now the question is we want ionic equation. So the best way to do is first you begin by writing the chemical equation, then from there you convert your chemical equation into the ionic equation. Now remember, when converting substances like this into ions, you just have to break those in aqueous phase. So we begin with sodium plus aqueous. Now for this number 2 here, if you want your ionic equation to be balanced, you need to put here in front. So this goes in front, then SO4 minus aqueous plus here we have barium with 2 aqueous plus nitrate has a minus aqueous, then these 2 here will go in front plus the barium, this would be the arrow. Then the barium sulfate is in solid state, so we don't have to ionize this one. Then we have sodium plus 2 in front, aqueous, so you only break those in aqueous solutions. Then after we've done this is our, we can say, overall ionic equation. Then after we have our overall ionic equation, now let's write our net ionic equation. So for net ionic equation, we need to get rid of the spectator ions. So how do we determine that these are spectator ions? So those ions that are in aqueous phase on both sides of our equation, like sodium is in aqueous, also here is in aqueous. Sulfate is in aqueous on the reactant, but in solid, so it's not a spectator ion. Barium, no. Then this one we cancel. Then this one also we cancel. So our final answer is barium plus sulfate giving us barium sulfate S44 solid. So this is our ionic net equation. So we go to question 5. Magnesium carbonate decomposes on heating to form magnesium oxide and carbon dioxide. Okay. Then construct a chemical equation for the decomposition of magnesium carbonate, including state symbols. So magnesium is in group 2, so it has a valence of 2. Carbonate has the chemical formula of CO3 with a valence of 2, so these 2 are even. So we can write our magnesium carbonate solid. Then it's a double arrow, but let's just focus on the single arrow. Then we are told we are getting magnesium oxide. So magnesium has a valence of 2, oxygen has a valence of 2, so this will give us MgO solid plus what else are we getting? Carbon dioxide, a gas. Now most of decomposition equations where you have a group 2 metal, they are almost or stable. I mean, not stable, but they are balanced. So if you look at this, it is a balanced chemical equation. Now let's go to question B. Calculate the relative formula mass of magnesium carbonate. So we have the chemical formula is magnesium. Here we have 1. Carbonate, there is 1. Oxygen, we have 3. So we can now begin. Mr is equal to magnesium multiplied by 1 plus carbon times 1 plus oxygen multiplied by 3. So if you go on the periodic table, magnesium has a mass number of 24 multiplied by 1. You have 12 times 1, 16 multiplied by 3. So 24 times 1 is 24 plus 12 plus C, we have 48, which is, if we add 48 plus 12 is 60 plus 24 is 84. So this is our final answer. This is what they wanted. Given that 21 kilograms of magnesium carbonate is heated, calculate the mass of magnesium oxide formed. So we have been given the mass of magnesium carbonate. Then our task is we want the mass of magnesium oxide. So the mass of magnesium carbonate is 21 kilograms. Then for magnesium oxide is the one we are finding, so we put X. Then step number 2 is we need to assign the relative formula mass according to each compound. So 84 is for magnesium carbonate. We write it here on the magnesium side. So we need to find the one for magnesium oxide. So say Mr is equal to magnesium multiplied by 1 plus oxygen multiplied by 1. Then magnesium 24 times 1 plus 16 multiplied by 1, which is, we have 24 plus 16 giving us 40 as our final answer. So we put 40, then we cross multiply. Then we have 84 times X will give us 84X. Then we'll just say 0. 4 times 1 is 4. Then 4 times 2 we have 840. So 21 times 40 is 840 divided by 84, also by 84. Then let's write it here. X is equal to, I'm getting 10 kilograms of magnesium oxide, and it's making sense. If this decomposition was if it decomposed completely, and we are assuming that if we didn't have any impurity in the magnesium carbonate, and according to the equation we are told this is 21, then here is 10 kilograms, then this must be 11 kilograms, so that if we add these two masses, must add up to this, if, remember, if there are no impurities and if this decomposed fully. Alright, then name a metal carbonate that would not decompose on heating like magnesium carbonate. So a metal carbonate, we may have sodium carbonate. So how do I know that this one will not decompose? As long as the metal is from group 1. So all group 1 elements are stable to heating, they do not decompose. If they decompose, it's only partially. So it depends on the reactivity of that particular element present in that metal compound. So we have 6. The grid below represents part of the periodic table with atomic numbers of some elements. Okay, so we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, then group 8. So using the grid above, state the atomic number of an element, which is the first one, an alkali. So an alkali is group 1. Now don't confuse group 1 to be an alkali. This is hydrogen. So hydrogen is just put there because of the valence of 1. So an alkali can be 3 and 11. So then number 2, a more reactive halogen. Halogen are group 7. Now when you go up, their reactivity increases, so it's 9. Then 3, a noble gas used in electric cables, so we have argon. So according to periodic table, argon has 10. Then 4, a solid element at room temperature which forms an ion with a charge of -2. So -2 are non-metals from group 6. Now which is a solid at RTP? This should be sulfur. So sulfur has the atomic of 16. So we put our 16 here. B1, use the actual symbols to construct a chemical formula formed by elements with atomic number 13. So according to my periodic table, 13 is aluminium, so Al, and the first shell has 3 electrons, the second 80, the outermost shell. So aluminium has a valence of 3, so we put our 3 here. Then 80, according to my periodic table, is oxygen. So first shell 2, second shell 6, so the valence is 2. So if we interchange, our chemical formula is Al2, then oxygen 3. Then for Roman number 2, give the physical state in which the compound in B1 above will exist at room temperature and pressure. So this is same as the ionic compounds solid at RTP. They only become ions whenever dissolved in water. Then 7, proteins are naturally occurring macromolecules. A1, define the term macromolecule. So this is same as a polymer. So say macromolecules a large organic compound made from small units called monomers. Then for Roman number 2, name another naturally occurring macromolecule. So it's natural number 1 in terms of occurrence, so it's not a man-made. So we can give, apart from proteins, we can give fats. Then if we want, also starch. Then B, proteins can be hydrolyzed to amino acid state, a suitable reagent and condition for this hydrolysis. So hydro, we should put water. So reagent, we just say water. Then the condition can be presence of sulfuric acid or just any acid. Then for C, the structure of a section of a protein can be represented as this. Then describe one similarity in the structure of a protein and the structure of nylon. So say they both made up of same amide linkage. So this linkage is found in both the nylon and the protein. Then Roman number 2, describe one way in which the structure of a protein differs from the structure of a nylon. So say structure of a protein is made up of main monomers. while a structure of nylon is made up of two monomers. So that's a difference that we can give, but there are so many differences, but I'm sure we can just end our, we still have one more question. So question 8, complete the table 8.1 below on the properties and the use of metal that depend on the property. The first part has been done for you. So property of a metal: high melting, boiling point, filament in the electric. Then making bells or drums, so the sound that has to do with the sonorosity or sonorous. Then ductile can be used to draw or to make wires. Then making ornaments, we can just say shiny, metals are shiny. Free electrons to make electric cables. Then question B, magnesium react with dilute nitric acid to form magnesium nitrate and a colorless gas. Construct a balanced chemical equation for this reaction. So we have magnesium plus nitric acid. So a metal plus an acid will give us salt. In our case, magnesium nitrate is a salt, plus hydrogen is always produced. So Mg, solid, plus nitric acid is HNO3 equals. Then we have magnesium nitrate. So magnesium has a valence of 2, so we put 2 here, plus hydrogen, the atomic, so we just need a 2 here, then our equation is balanced. So that's it for this video, and I just want to remind you that I've got you guys covered. I have solved the biology, mathematics, paper 1 and 2, science paper 1 and 2, even if English. Have these papers solved from 2002 up to 2023 GCE. So you can just search for the paper that you want. They are all solved. So that's it for this video. Thanks for watching.